In a quiet Swedish observatory, Dr. Beatriz Villarroel uncovered a mystery frozen in time. 3 points of light captured on a 1952 Palomar plate, and then nothing. Gone, as if switched off. The next day, UFOs filled the skies over Washington, D.C. 70 years later, another object, 3I Atlas, crosses the same path, same geometry, same signature, same impossible odds. Its trajectory matches that ancient flashpoint almost perfectly, too perfectly to dismiss. Coincidence, or continuity. And when it brushed past the sun, the star erupted with 3 coronal mass ejections in perfect rhythm, as if it were feeding the visitor. Was it refueling? If so, has it done this before? Was 1952 a rehearsal for a mission that's finally begun? Stay until the end, because tonight, we connect the dots and reveal what might be the second act of a story, 70 years in the making. And if these mysteries have you on edge the way they have me, don't just watch in the shadows. Hit like, subscribe, and turn on the notifications, because you don't want to miss any update as this story continues to unfold. Tell me in the comments where you're watching from, what time it is there, and what you think about this new development. And if you want to help this community grow, share this video on X, Facebook, Reddit, or even just in your group chats. You're the reason we can keep digging deeper. Thanks for having our back. Part 1. The Smoking Gun. Picture this. July 19th, 1952. Mount Palomar Observatory, California. A massive telescope captures light from the cosmos onto photographic plates, sheets of glass coated with light-sensitive emulsion. These plates are time capsules, freezing moments of the universe for decades to come. On that particular night, 3 points of light appeared on the plates, 3 pinpoint sources, bright enough to register clearly. They sat there in the darkness of space, arranged in a tight cluster. Then, on the next exposure of the same patch of sky, they were gone, vanished. No trace, no afterglow, no explanation. 3 lights, 1 night, then nothing. Now, you might think this is just astronomical noise, some artifact of old equipment, a cosmic ray striking the emulsion, perhaps a flaw in the glass itself. But here's where it gets strange. These 3 transients, as astronomers call them, appeared in a very specific location in the sky. They showed up at the intersection of 2 fundamental planes that govern our cosmic neighborhood: the ecliptic plane, where Earth and the planets orbit, and the galactic plane, the disk of our Milky Way galaxy. The odds of a random transient appearing exactly there, roughly 1 in 10,000. But wait, it gets stranger still. 1 day later, July 20th, 1952, the skies over Washington, D.C. erupted with one of the most documented mass UFO sightings in American history. Multiple radar installations tracked unknown objects moving at impossible speeds. Air traffic controllers watched them on their screens, pilots scrambled to intercept them, civilians pointed at lights dancing across the night sky above the nation's capital. The incident made front-page news. It terrified the public. It baffled the military. 2 events, separated by 24 hours. 1 in the astronomical record hidden on glass plates for 70 years. 1 in the historical record witnessed by hundreds. Coincidence? Maybe. But let me introduce you to Dr. Beatriz Villarroel, an astrophysicist who has spent years combing through those old Mount Palomar plates, searching for anomalies. Her work began innocently enough. She was looking for signs of Dyson spheres, hypothetical megastructures that advanced civilizations might build around stars. What she found instead was far more unsettling. She discovered a statistical pattern. Transients, those mysterious vanishing points of light, appeared 45% more often within 1 day of a nuclear test, 68% more often on the day immediately after a nuclear test, and for every additional UAP report filed on a given day, the likelihood of a transient appearing increased by 8.5%. Think about what that means. These aren't just random flickers on old plates, they're correlated. They're connected to our activities down here on Earth, to our most destructive technology, to our atomic age, to moments, when we split the atom and announced our presence to the cosmos with the force of miniature suns. Now, fast forward to 2025, July 1st to be exact. The Atlas survey, an automated system that scans the sky for asteroids and other moving objects, detects something new. An object, coming from outside our solar system, moving on a hyperbolic trajectory. Interstellar. They name it 3-Eye Atlas, the third confirmed interstellar object ever detected by humanity. It's approaching the Sun, heading for perihelion, its closest pass on October 29, 2025. Right about now, as you're watching this, here's where your spine should start to tingle. This object, 3-Eye Atlas, has an unusual orbit. It's aligned with the ecliptic plane in ways that make astronomers scratch their heads. Its composition is strange, rich in carbon dioxide, with an odd ratio of nickel to iron in its coma, the cloud of gas and dust surrounding it. It doesn't behave quite like other comets. And its trajectory? Well, let me put it this way. If you trace its path backward through space, if you project where it came from and compare it to those coordinates from 1952, you start to see something that should be impossible. Could an object seen in 1952 be related to what we're seeing now with 3-Eye Atlas? Let me be clear. I'm not asking if it's the same object. I'm asking if it could be connected. If whatever left those 3 points of light on Mount Palomar plates might be making a return visit 73 years later. Because here's what makes this more than just pattern-seeking and conspiracy thinking. As 3-Eye Atlas swings past the Sun this October, the Sun itself is behaving strangely. Coronal mass ejections, massive eruptions of plasma and magnetic fields from the solar surface have been firing off with unusual timing. October 21st, October 23rd, October 25th, October 26th. Each one releasing energy equivalent to tens of Hiroshima bombs. Each one happening right as this mysterious object makes its closest approach. Coincidence? Natural solar activity? Or something else entirely? What if 3-Eye Atlas isn't just a comet? What if it's a probe, an intelligence? What if it was here before, announcing its presence with those 3 bright flashes in 1952, one day before the Washington sighting? What if it's been on a decades-long elliptical orbit, swinging back through our neighbourhood, and what we're witnessing now isn't random solar activity but something far more deliberate, an advanced object using our star as a refueling station? I know how that sounds. Believe me, I do. But stick with me, because over the next several parts we're going to walk through the evidence piece by piece. We're going to examine Dr. Villarroel's data. We're going to map the geometry of that 1952 transient against the trajectory of 3-Eye Atlas. We're going to dive into the physics of coronal mass ejections and ask whether it's even theoretically possible for an object to harness that energy. And we're going to confront the uncomfortable question at the centre of all this. If we're not alone, if an intelligence has been watching us since we entered the atomic age, what does it want? Why come back now? And what happens next? Part 2. Update on 3-Eye Atlas and its anomalies. Let me bring you up to speed on what we actually know about 3-Eye Atlas, stripped of speculation, grounded in the official record. The object was discovered on July 1st, 2025, by the Asteroid Terrestrial Impact Last Alert System, known as ATLAS. This is a robotic early warning system, a network of telescopes designed to scan the night sky for asteroids that might threaten Earth. It's automated, tireless, and very good at catching things that move against the background of stars. When ATLAS flagged this object, astronomers immediately noticed something unusual about its velocity. It was moving too fast. Not asteroid fast. Not even comet from the outer solar system fast. It was moving at interstellar speed, meaning it didn't originate from our Sun's gravitational family. It came from somewhere else in the galaxy. They calculated its orbit. The math was clear. 3-Eye Atlas follows a hyperbolic trajectory, an open curve, not a closed ellipse. It's not bound to our Sun. It's passing through. A visitor. This makes it only the third confirmed interstellar object we've ever detected. The first was 1I/Oumuamua, that strange cigar-shaped tumbler that zipped through in 2017 and sparked endless debate about whether it was a natural object or something artificial. The second was 2I/Borisov, a more conventional-looking comet discovered in 2019, and now we have 3-Eye Atlas. But 3-Eye Atlas is different. Let me explain how. Its perihelion, the point where it comes closest to the Sun, occurs on October 29th, 2025. That's right around now. At its nearest, it comes within roughly 0.3 astronomical units of the Sun. For reference, Earth sits at 1 astronomical unit. So it's diving in closer to the Sun than we are, though not as close as Mercury, close enough to heat up significantly, close enough to become very difficult to observe because it enters the sun's glare. That timing matters. Observing windows are everything in astronomy. After perihelion, as 3i Atlas swings back out into space, it will fade quickly, becoming too dim for most telescopes to track. This October pass is our best chance to study it, maybe our only chance. Now, let's talk about what makes this object physically strange. First, its coma, the cloud of gas and dust that surrounds the nucleus, is unusually rich in carbon dioxide. Most comets show a strong signature of water vapor when they heat up near the sun. 3i Atlas, it's releasing CO2 at a much higher ratio compared to H2O. That's odd. It suggests the object formed in a very cold CO2-rich environment, possibly far from any star, in the depths of interstellar space. Second, spectroscopic observations have revealed an unusual ratio of nickel to iron emission lines in the coma. Normally, comets outgas material in predictable proportions based on their composition. 3i Atlas doesn't fit the pattern. The nickel-to-iron ratio is higher than expected. What does that mean? Honestly, we don't know yet. It could indicate an unusual formation history. It could suggest contamination from a different kind of stellar environment, or it could hint at something we haven't seen before. Third, the dust and gas production behavior has been erratic. As comets approach the sun, they typically brighten in predictable ways. More heat means more outgassing, which means more reflected light. 3i Atlas has shown variations that don't quite match the standard models. It's brightening, yes, but not smoothly. There are fluctuations, bursts, dips. Astronomers are still trying to model what's causing that. And then there's the orbit itself. This is where things get subtle but significant. 3i Atlas's trajectory is aligned with the ecliptic plane, the flat disk where Earth and the other planets orbit the Sun, in a way that's statistically uncommon for interstellar objects. Most visitors from deep space come in at random angles because space is three-dimensional and isotropic. There's no preferred direction. Yet 3i Atlas arrived along a path that suggests it approached from within or near the plane of our solar system. Now some astronomers have noted possible anomalies in its trajectory, slight deviations from what a purely gravitational orbit would predict. These are called non-gravitational accelerations. Comets experience them all the time due to outgassing. Jets of gas act like tiny rocket engines, nudging the comet slightly off course. But the deviations observed in 3i Atlas are being scrutinized. Are they consistent with normal cometary activity, or is something else going on? Here's where we enter speculative territory, but it's speculation grounded in observation. People are asking whether 3i Atlas is doing something more than just passively falling through the solar system. What if it's adjusting? What if those bursts of gas aren't random outgassing but deliberate maneuvers? And here's where the story takes a darker, more fascinating turn. As 3i Atlas makes its closest pass to the sun itself is erupting. Coronal mass ejections, enormous clouds of plasma and magnetic fields, are being hurled into space. These CMEs carry staggering amounts of energy, the equivalent of millions of nuclear bombs. They happen regularly during the solar cycle, but the timing and direction of recent ones have raised eyebrows. Let me pose a hypothesis, one that we'll explore in detail later. What if 3i Atlas isn't just a passive comet? What if it's an advanced object capable of exploiting solar activity? What if those CMEs aren't coincidental but triggered or anticipated? What if an intelligence could position itself in the path of a coronal mass ejection and absorb that energy, use it to recharge, to decelerate, to change course? I know. It sounds like science fiction. But here's the thing. We've never encountered an interstellar intelligence. We have no idea what their technology would look like. We have no idea what energy sources they'd exploit. And if you were designing a probe to travel between stars, to visit solar systems, wouldn't you want a way to refuel? Wouldn't you look at a star, a massive reliable fusion reactor, and think, there's my energy source? That's the question hanging over 3i Atlas. Is it just a comet, following the cold physics of gravity and sublimation? Or is it something more, something waiting, something preparing as it swings past our sun in these final days of October 2025? Part 3. Statistical patterns in the 1950s transient data. Now we need to rewind. Back to the 1950s. Back to Mount Palomar Observatory and those glass photographic plates that captured slices of the night sky. Exposure by exposure, year after year. Mount Palomar was home to the Hale telescope, which for decades was the largest optical telescope on Earth. From 1949 through 1957, this telescope systematically photographed the sky. Each plate covered a patch of the heavens. Each plate was a time-stamped record. Together they formed an archive of the universe as it appeared during one of the most turbulent eras in human history, the dawn of the atomic age. Dr. Beatriz Villarroel didn't set out to study UFOs. Her background is in astrophysics, specifically the search for technosignatures, evidence of advanced civilizations. She was interested in Dyson spheres, hypothetical structures that a sufficiently advanced species might build around a star to harvest its energy. Such a structure would create a distinctive infrared signature, a star that dims in visible light but glows in infrared. She thought maybe, just maybe, she could find one by comparing old sky surveys to modern catalogues, looking for stars that had vanished or changed dramatically. What she found instead was far stranger. Transients. Lots of them. A transient in this context is a point source of light that appears in one photographic plate and disappears in the next. It's there, then it's not. In modern astronomy, transients are common. They include supernovae, variable stars, asteroids, cosmic rays hitting the detector. But these old plates were different. They were analog. They captured photons directly onto light-sensitive emulsion. And when Villarroel cross-referenced them with modern digital sky surveys, she found hundreds of objects that appeared once and never again. Some of these could be explained. Plate defects, cosmic rays, calibration errors. But a significant number could not. They appeared in the right parts of the sky, at the right magnitudes, with the right characteristics to be real, astronomical events. But they had no follow-up, no supernova remnant, no variable star, nothing. Villarroel began to wonder if some of these transients might be artificial. So she did what any good scientist would do. She looked for patterns. She compiled a database of transients from the Mount Palomar plates covering 1949 to 1957. Then she cross-referenced this data with two external datasets, nuclear test schedules and UAP reports from the same era. The results were shocking. Transients were 45% more likely to appear within 1 day of a nuclear test. Not just any nuclear test, but specifically atmospheric tests, the ones that released massive amounts of energy and radiation into the environment, the ones that created visible fireballs and mushroom clouds, the ones that announced to the cosmos, if anyone was watching, that humans had unlocked the atom. Even more striking, transients were 68% more likely on the day immediately after a nuclear test. The effect was delayed, as if whatever was creating these transients needed time to respond or arrive. And then there was the UAP correlation. For every additional UAP report filed on a given day, reports from pilots, radar operators, civilians, there was an 8.5% increase in the probability of a transient appearing in the sky that same day. Let me be clear about what this means statistically. These aren't small effects. 45% and 68% increases are huge. They're well above the threshold for statistical noise. And the fact that they correlate with two independent datasets, nuclear tests and UAP reports, makes random chance an increasingly uncomfortable explanation. Villarroel's methodology was rigorous. She wasn't cherry-picking data. She wasn't starting with a conclusion and working backward. She took a complete dataset of transients, a complete record of nuclear tests, and a complete archive of UAP reports. And she let the statistics speak. And what they said was, something was happening in the sky during the 1950s that was linked to nuclear activity and to whatever people were seeing and reporting as unidentified aerial phenomena. Now, let's talk about why this is hard to dismiss as observer bias. Observer bias happens when researchers unconsciously skew their data to fit their expectations. But Villarroel was analysing plates that had been sitting in archives for 70 years. The transients weren't discovered contemporaneously. Nobody in 1952 looked at a plate and said, "Oh look, a UFO just flew past." The anomalies were found decades later by comparing old plates to modern catalogues, using algorithms and statistical methods that didn't exist in the 1950s. The data was locked in glass. It couldn't be contaminated by Cold War paranoia or UFO hysteria. Of course, there are potential confounding factors. Plate quality varied, coverage varied. Some parts of the sky were photographed more often than others, Some nights had better atmospheric conditions, some plates were better calibrated, and nuclear test sites were concentrated in specific geographic locations: Nevada, the Pacific, Kazakhstan. Could that introduce a geographic bias into the transient distribution? Possibly, but Villarroel controlled for these variables as much as the data allowed, and yet, even accounting for these factors, the correlations hold. The probability that this is all just coincidence drops to uncomfortable levels. Something was leaving marks in the sky during the atomic age, and those marks were correlated with our activities. Critics, understandably, remain skeptical. They point out that correlation is not causation. Just because transients and nuclear tests happen near each other in time doesn't mean one caused the other. Maybe there's a third variable we haven't identified. Maybe it's an artifact of how the data was collected or analysed. Maybe it's a fluke. But here's the thing about flukes. They don't tend to line up with other flukes. And that's where the triple transient of July 19th, 1952 comes in. Part 4. Trajectory. Coincidence and mission profile theory. Let me paint a picture of cosmic geometry for you. Imagine you're floating in space, looking at our solar system from the side. You'd see the sun at the centre and the planets arranged in a flat disk around it. That disk is called the ecliptic plane. It's the fundamental plane of our solar system, the reference against which we measure everything. Now pull back further. Zoom out until you can see the entire Milky Way galaxy. Our galaxy is also a disk, a spiral of stars and gas rotating around a supermassive black hole at the centre. That disk is called the galactic plane, or the galactic equator. These two planes, the ecliptic and the galactic, intersect. They cross each other at a specific line in the sky. If you're standing on Earth and you look up at night, there are 2 points where this intersection is most apparent. One toward the constellation Taurus, the other towards Sagittarius. These are special coordinates. They're the hinges of our cosmic neighbourhood. Now, here's the key fact. The triple transient of July 19th, 1952, those 3 points of light that appeared and vanished on Mount Palomar plates, occurred at a location in the sky that was extremely close to this intersection, within 1 degree, by some estimates. The odds of a random transient appearing at that exact spot are roughly 1 in 10,000. Why does this matter? Because if you were an advanced intelligence travelling through the galaxy, and you wanted to enter a solar system, you'd probably do it along one of these natural reference planes. You'd align your approach with the ecliptic, because that's where the planets are, that's where the resources are, that's where any civilization would be. And if you were coming from interstellar space, you'd likely arrive along the galactic plane, because that's the most efficient path through the galaxy. In other words, the intersection of these 2 planes is the cosmic equivalent of a major highway interchange. It's where you'd expect traffic, it's where you'd expect arrivals, and that's exactly where the triple transient appeared. But it gets better, or worse depending on your perspective. Let's think about what those 3 transients might represent. One interpretation is that they're random, 3 unrelated objects that happen to appear in the same patch of sky at the same time. But there's another interpretation, one that's more chilling. What if those 3 points of light were propulsive bursts? What if they were engines firing? Think about it. You're an interstellar probe arriving at a new solar system. You've been coasting for decades, maybe centuries, covering light years of distance. Now you need to decelerate. You need to slow down enough to enter orbit around the target star or around a planet. How do you do that? You fire your engines. And if you're using something exotic, plasma rockets, fusion torches, antimatter drives, those engines would shine, they'd be visible, they'd leave a signature in the sky, 3 bursts, 3 points of light, a controlled deceleration, a mission profile, and then, 1 day later, the mass UFO sighting over Washington, D.C., dozens of objects tracked on radar. Pilots scrambled, the nation's capital in an uproar, the timing is impossible to ignore. Now let's bring this forward to 2025. Let's talk about 3I Atlas and its trajectory. When astronomers calculated the orbit of 3I Atlas, they found something unusual. Its path, when traced backward through space, suggests it approached our solar system from a direction that aligns with the ecliptic plane. Not perfectly, but close enough to be statistically interesting. And when you compare the coordinates of its inbound trajectory to the location of that 1952 triple transient, the geometry starts to overlap. Could 3I Atlas be following the same path? Could it be arriving at the same cosmic intersection? Here's the speculative leap, and I want to be clear that this is not proven. not confirmed, not accepted by mainstream astronomy, but let's entertain it. What if the triple transient of 1952 was the arrival of an object, an intelligence, a probe that used that intersection point as an entry corridor into our solar system? What if it decelerated using those 3 propulsive bursts, inserted itself into an orbit, and spent the next 73 years doing whatever it came here to do? And what if 3I Atlas is Atlas, that same object, or a related object making a second pass? The timescale fits. 73 years is a plausible orbital period for an object moving in a highly elliptical trajectory around the Sun. It's longer than Halley's Comet, but not absurdly so. If you wanted to design a probe that visited a solar system, performed observations, and then swung back out into interstellar space before returning decades later, 73 years is a reasonable mission duration. Of course, this raises questions. Enormous questions. How would such an object decelerate without us noticing it for 70 years? Where was it between 1952 and 2025? Why didn't we detect it with modern telescopes? One possibility: stealth. If the object spent most of its time in the outer solar system, far from the Sun, it would be extremely difficult to detect. It would be cold, dark, moving slowly. Our telescopes are optimized for finding things that reflect sunlight or emit their own light. A dormant probe coasting through the Kuiper belt would be nearly invisible. Another possibility: small size. If the object is small enough, say, a few hundred meters across, it would blend in with asteroids and comets until it became active again, until it started out gassing and producing a coma as it approached the Sun, which is exactly what 3I Atlas is doing now. But here's the uncomfortable question that keeps gnawing at me. If this is true, if 3I Atlas is a return visitor, why now? What triggered its return? What's different about 2025? And why is the Sun erupting with coronal mass ejections right as it makes its closest pass? Part 5. Connecting Past and Present. Is 3I Atlas a return visit? Let me lay out everything we have so far, piece by piece, and see if it holds together. 1952. A triple transient appears on Mount Palomar plates, 3 points of light, arranged in a tight cluster, located near the intersection of the ecliptic and galactic planes. 1 day later, mass UFO sighting over Washington, D.C. Statistical analysis shows transients from this era are correlated with nuclear tests and UAP reports at levels far exceeding chance. 2025. An interstellar object, 3I Atlas, is discovered on a hyperbolic trajectory. Its orbit is aligned with the ecliptic plane in an unusual way. Its composition is strange, high Ko2, odd nickel-to-iron ratio. It exhibits erratic outgassing behavior. As it approaches perihelion, the Sun releases multiple coronal mass ejections in rapid succession. Now let's ask the hard question. Is this coincidence or connection? To answer that, we need to look at the geometry more closely. When did 3I Atlas cross the ecliptic plane? When did it pass through the region of sky near that cosmic intersection? And more importantly, when you trace its trajectory backward, does it point toward the same coordinates where the triple transient appeared 73 years ago? The data here is frustratingly incomplete. 3I Atlas's orbital elements are known to a certain precision, but there are uncertainties. Small errors in position and velocity measurements propagate over time, especially for hyperbolic orbits. Tracing its path backward through 7 decades of gravitational interactions with the Sun and planets introduces compounding uncertainties. But the rough alignment is there. The trajectories overlap within the margin of error. So yes, it's possible. It's geometrically plausible that 3I Atlas could be following a similar path to whatever created that 1952 transient. Now let's talk timescales. 73 years. That's the gap between July 1952 and October 2025. For a human, that's a lifetime. For an interstellar mission, it's a blink. If you're an advanced civilization launching a probe to another star system, you're thinking in terms of centuries or millennia. The nearest star to us, Proxima Centauri, is over 4 light-years away. Even travelling at 10% the speed of light, a speed we can't remotely achieve with our current technology, it would take 40 years just to get there. Add in time to decelerate, observe and return, and you're looking at a century-long mission minimum. But what if the mission profile is different? What if the probe isn't travelling between stars at constant speed? What if it's using gravity assist, slingshot manoeuvres around stars, periodic accelerations and decelerations. What if it's designed to visit a solar system, spend a few decades in the outer regions observing, then swing back through for a closer pass before departing again? In that case, 73 years makes sense. It's a single orbit, a reconnaissance loop. An object arrives, inserts into a long elliptical orbit, spends time in the cold outer solar system where it's nearly undetectable, then returns for a close pass by the Sun, close enough to refuel, close enough to gather more data, close enough to send a signal back home. But let's be honest about the objections here. There are many, and they're strong. First, coincidence is real. Humans are pattern-seeking creatures. We see faces in clouds. We see meaning in randomness. The fact that two objects share a similar trajectory doesn't prove they're related. It might just be that the intersection of the ecliptic and galactic planes is a common entry point for interstellar objects purely due to the geometry of our galaxy. Maybe many such objects pass through that region simply because it's part of the galactic disk. Second, the transient data from Mount Palomar is old and uncertain. Photographic plates are subject to errors, emulsion defects, cosmic ray hits, registration problems when comparing plates taken years apart. The transients Villarroel identified could be artifacts. The statistical correlations could be spurious, the result of multiple testing, or selection bias. Maybe researchers are finding patterns because they're looking for patterns. Third, 3I Atlas might simply be a weird but natural comet. Interstellar space is diverse. Objects forming in other stellar systems would have different compositions, different chemical makeups depending on their birth environment. A CO2-rich coma isn't impossible for a natural object. Erratic outgassing can happen when pockets of volatile material heat unevenly as the comet rotates. Non-gravitational accelerations are normal for comets. Nothing about 3I Atlas definitively screams artificial. Fourth, even if we accept the trajectory coincidence, that doesn't prove intentionality. Space is big, really big. The odds of an object passing through any given patch of sky are low, but not astronomically low. Over billions of years, over the vast number of interstellar objects that likely pass through our solar system undetected, some of them are bound to line up with interesting coordinates purely by chance. And yet, when you stack all the coincidences together, the triple transient, the Washington sighting, the statistical correlations, the trajectory alignment, the timing, the solar activity, the probability that this is all random starts to strain credulity. Let me pose a thought experiment. If an advanced intelligence wanted to visit our solar system, how would it do so? It would likely send a probe, not a crewed mission. The probe would be small, automated, resilient. It would need to survive decades or centuries in deep space. It would need a power source, and it would need a way to adjust its trajectory to slow down to enter orbit. The most obvious energy source in any solar system is the star itself. Our sun outputs more energy in 1 second than humanity has used in all of history. If you could tap even a tiny fraction of that, you'd have more than enough to power a probe indefinitely. How do you tap it? One way is solar radiation. Just collect sunlight with big reflective surfaces or photovoltaic panels. But that's passive and limited. Another way, more exotic, is to harness solar wind or coronal mass ejections. Those are particle streams carrying kinetic and magnetic energy. If you had the right kind of collector, a magnetic field, a cloud of nanoscale absorbers, you could intercept a CME and extract usable energy from it. That's the hypothesis we're dancing around. That 3I Atlas isn't just falling past the sun, it's interacting with it. It's waiting for CMEs, positioning itself in their path, and using them as a refueling mechanism, which brings us to the final act of this story. The coronal mass ejections happening right now, the ones firing off as 3I Atlas makes its closest approach. Are they random? Or are they part of something larger, something we're only beginning to glimpse? If 3I Atlas is a return visitor, if it was here in 1952, and it's here again now, then we're watching something unprecedented. We're watching an intelligence operate on timescales that dwarf our own. We're watching a mission that spans human lifetimes, that transcends generations, that treats decades the way we treat days. And if that's true, the question isn't just what it wants. The question is, what happens when it leaves? Will it be another 73 years before it returns? Or is this the last pass? Is this goodbye? Part 6. CME Comet Interaction and Energy Absorption Hypothesis. Coronal Mass Ejections. Let me explain what these are. because understanding them is key to understanding the most speculative and most fascinating part of this entire theory. The Sun is not a calm, stable sphere. It's a roiling ball of plasma, a fusion reactor held together by gravity, threaded with magnetic fields that twist and snap like rubber bands. Periodically, those magnetic fields become unstable, they erupt, and when they do, they hurl billions of tons of plasma into space at speeds reaching millions of miles per hour. That's a coronal mass ejection, a CME. These events are common. The Sun goes through an 11-year cycle of activity, and during solar maximum, CMEs can happen multiple times per week. Most of them miss Earth entirely. They spray out into space in random directions. But occasionally one heads our way, and when it hits, it compresses Earth's magnetosphere, triggers auroras, disrupts satellites, interferes with power grids. A typical CME carries energy on the order of 10 to the 20 joules. To put that in perspective, the atomic bomb dropped on Hiroshima released about 10 to the 13 joules. So a single CME carries energy equivalent to tens of millions of Hiroshima bombs. It's an almost incomprehensible amount of power. Now, let's talk about what happened in October 2025 as 3I Atlas approached perihelion. October 21st, a CME erupted from the Sun's surface. Moderate strength, directed roughly toward Earth's orbital plane. October 23rd, another CME, stronger, plasma ejected at higher velocity. October 25th, yet another. This one originated from an active region near the solar equator. October 26th, a fourth CME, shortly before 3I Atlas reached its closest approach to the Sun. 4 coronal mass ejections in 6 days, during a period when 3I Atlas was deep in the inner solar system, passing within 0.3 astronomical units of the Sun. Is this normal? Sort of. October 2025 falls during an active phase of the solar cycle, so multiple CMEs aren't unusual, but the timing raises questions, the frequency raises questions, and the direction, whether any of these CMEs were aimed toward the region of space where 3I Atlas was located, raises even more questions. Unfortunately, detailed data on the directionality of these specific CMEs isn't fully public yet. Solar observatories like the Solar Dynamics Observatory and the Solar and Heliospheric Observatory record CMEs constantly, but passing their trajectories, modelling their propagation through the heliosphere, and determining which objects they might intercept requires significant analysis. That work is ongoing. But let's assume, hypothetically, that one or more of these CMEs intersected 3I Atlas's position. What would happen? For a natural comet, not much. The comet's coma would light up temporarily as the charged particles interacted with the gas and dust. There might be some increased tail activity, but the comet itself wouldn't absorb any meaningful energy. Comets don't have mechanisms to capture and store the kinetic and magnetic energy carried by plasma. But what if 3I Atlas isn't a natural comet? Let's entertain the hypothesis. Suppose it's an artificial object, or at least a partially artificial object, a probe encased in ice and dust to disguise itself as a comet. Suppose within that coma, that cloud of gas and dust, there's a network of nanoscale machines, microscopic collectors, magnetic field generators, energy absorbers distributed throughout millions of cubic kilometers of space. When a CME hits, it delivers a pulse of charged particles, protons, electrons, helium nuclei, all moving at incredible speeds, all carrying kinetic energy. It also carries magnetic field energy, embedded in the plasma itself. If you had the right kind of collector, you could intercept those particles, slow them down, and convert their kinetic energy into something usable. You could use magnetic fields to channel the plasma, to concentrate it, to extract work from it. How much energy are we talking about? Let's do some rough math. A CME releases about 10 to the 20 joules total. But that energy spreads out as the CME expands into space. By the time it reaches Earth's orbit, only a tiny fraction of that energy intersects Earth's magnetosphere. An object the size of a comet, say, a few kilometers across, would intercept an even smaller fraction. But even a small fraction of 10 to the 20 joules is enormous. If 3I Atlas intercepted just 1/1,000,000th of a CME's total energy, that's still 10 to the 14 joules. That's equivalent to roughly 45 Hiroshima bombs, concentrated into an object a few kilometers wide. Could that energy be harnessed? Could it be used? Theoretically, yes. If you had a sufficiently advanced technology, superconducting coils to generate magnetic fields, nanoscale absorbers to capture particles, some kind of storage system to hold the energy. You could, in principle, use a CME as a refueling station. You could siphon energy from the sun's eruptions. Why would you want to? Because interstellar travel is an energy problem. Moving even a small probe between stars requires staggering amounts of energy. Accelerating to a significant fraction of light speed, then decelerating again at your destination, costs more energy than we've generated in all of human history. If you're an intelligence planning such a mission, you need a way to refuel, and stars are the most obvious energy source. They're everywhere. They're predictable. They output massive amounts of power continuously. But there's a problem. Ordinary solar radiation, sunlight, is diffuse. Collecting it requires enormous surface areas like solar sails. Coronal mass ejections, on the other hand, are concentrated bursts. They deliver huge amounts of energy in a short time. If you could predict them, or even trigger them, you'd have a much more efficient refueling mechanism. And here's where it gets truly speculative. Could an advanced object trigger a CME? Could it manipulate the sun's magnetic field to cause an eruption? On the face of it, this sounds absurd. The sun is enormous. Its magnetic fields are generated deep in the interior by convection and differential rotation. How could a tiny object possibly influence something that massive? But consider this. CMEs are triggered by instabilities in the sun's magnetic field. Those instabilities form in active regions, areas where magnetic field lines are twisted and stressed. It doesn't take much to push an already unstable region over the edge. A small perturbation at the right moment could cause a cascade, releasing a CME that was already building. Could 3i Atlas do that? Could it send a pulse of electromagnetic energy into the sun's corona? Could it inject charged particles in just the right place to destabilize a magnetic loop? I don't know. Nobody knows. We've never seen anything attempt it. We don't even know if it's physically possible. But the fact that multiple CMEs erupted during 3i Atlas's perihelion pass is, at minimum, an interesting coincidence. Now let's talk about the flip side. What are the problems with this hypothesis? First, surviving near the sun is incredibly difficult. The radiation environment is brutal. Temperatures soar. Any object, natural or artificial, would be bombarded by ultraviolet light, X-rays, and particle radiation. Shielding against that requires mass, which means more weight, which means more energy needed to move the object. There's a trade-off. Unless you had some exotic material, something beyond our current technology, it's hard to imagine how a probe could withstand that environment for long. Second, absorbing energy from a CME is inefficient. Most of the particles would miss. Most of the energy would spread out into space. You'd need an enormous collection area to capture a meaningful fraction. And if you're trying to stay hidden, to disguise yourself as a comet, having a giant energy collection apparatus would rather defeat the purpose. Third, we have no direct evidence of any of this. No anomalous magnetic fields detected around 3i Atlas. No unexplained radio emissions. No spectral signatures that can't be explained by normal cometary chemistry. Everything we've observed so far is consistent with a weird but natural object. And yet the timing of those CMEs nags at me. 4 eruptions in 6 days, right as an interstellar object makes its closest pass to the sun. If this were a novel, it would be too convenient. Reality is supposed to be messier, more random. But what if it's not? What if we're watching something that's been planned for decades, executed with precision we can barely comprehend? If 3i Atlas is refueling, if it's using our sun as an energy source, then it's not just passing through, it's preparing. For what? To adjust its trajectory? To send a signal home? To wake up systems that have been dormant for 73 years? Or maybe, just maybe, to do what it did in 1952, to announce its presence, to let us know we're not alone. Part 7. Critique and Counterarguments. Let me step back now and do something uncomfortable. Let me tear apart everything I've just told you, because if this hypothesis is going to stand, it needs to withstand serious scrutiny. And the scrutiny is fierce. The mainstream astronomical community, the professional scientists who study comets and interstellar objects for a living, would look at this 3i Atlas's alien probe theory and say, extraordinary claims require extraordinary evidence, and we don't have extraordinary evidence, we barely have suggestive evidence. Let's start with the Mount Palomar transients. Yes, Dr. Villarroel found statistical correlations between transients, nuclear tests, and UAP reports. But correlation is not causation. Statistics can be misleading, especially when you're mining large datasets for patterns. Consider this. The Mount Palomar archive contains thousands of photographic plates covering hundreds of thousands of square degrees of sky over nearly a decade. That's a lot of data, and when you have a lot of data, you're guaranteed to find some correlations purely by chance. It's called the multiple comparisons problem. If you test enough relationships, some of them will look significant even if they're random. Maybe transients appear more often near nuclear tests, because both are recorded more thoroughly during periods of heightened military and scientific activity. Maybe observers were more careful, took more plates, during tense Cold War moments when everyone was watching the skies. That would create an artifact correlation that has nothing to do with cause and effect. Or maybe the transients aren't real astronomical events at all. Photographic plates are fragile things. The emulsion can degrade. Cosmic rays can strike the plate directly, leaving false signals that look like stars. Registration errors, slight misalignments when comparing plates taken years apart, can make stationary objects appear to vanish. Dust on the telescope optics, flaws in the glass, chemical contamination of the emulsion, all of these can create spurious signals. Villarroel tried to control for these factors, but it's impossible to eliminate them entirely. The data is 70 years old. We can't go back and retake those observations. We're stuck with what we have, and what we have is imperfect. Now, let's address the triple transient itself. 3 points of light appearing near the intersection of the ecliptic and galactic planes. 1 in 10,000 probability. Sounds impressive. But here's the problem. That probability estimate depends on assumptions about how transients are distributed across the sky. If those assumptions are wrong, if transients are more common near the galactic plane for natural reasons, for example, then the probability changes dramatically. Also, selection bias. Villarroel was looking for anomalies. She found an anomaly that happened to line up with a famous UFO sighting. But how many other transients from that era don't line up with anything? How many false positives did she ignore because they didn't fit the narrative? If you search long enough through any dataset, you'll find something that looks meaningful. And then there's the Washington, D.C. UFO sighting itself. Yes, it happened. Yes, it was documented. But documented doesn't mean explained, and unexplained doesn't mean alien. Radar systems in 1952 were primitive by modern standards. They produced false returns constantly, reflections off weather inversions, temperature gradients, flocks of birds. The objects tracked that night could have been atmospheric phenomena misinterpreted as solid objects. Pilots scrambled, people panicked, but fear and confusion don't equal evidence. The fact that the event remains officially unexplained doesn't mean it's inexplicable. It means we don't have enough data to explain it. Now, 3i Atlas. Let's talk about why astronomers think it's just a comet. First, its behavior is broadly consistent with cometary physics. It has a coma, it's outgassing, it's brightening as it approaches the sun. These are all things comets do. The fact that its composition is unusual, high CO2, odd nickel to iron ratio, doesn't make it artificial, it makes it interesting. Interstellar objects formed in different stellar environments would naturally have different compositions. We've only detected 3 of these objects ever. We don't have a large enough sample size to say what's normal and what's not. Second, the non-gravitational accelerations observed in 3i Atlas are small and consistent with uneven outgassing. Comets are lumpy, irregular objects. They rotate. As they heat up, jets of gas erupt from sunlit areas, creating tiny rocket thrust effects. These jets are random, asymmetric. They cause the comet to wobble and drift slightly off its predicted path. That's exactly what we see. Third, there's no signal. If 3i Atlas were an artificial probe, we'd expect it to emit something. Radio waves, laser pulses, some kind of communication or data transmission. Radio telescopes have observed it. Nothing. Just the normal emissions you'd expect from a comet. Spectral. Lines from molecules like CO2, CN, water. No anomalous signals, no beacons. Fourth, Occam's razor. The principle that the simplest explanation is usually correct. What's simpler? 3i Atlas is a weird comet from another star system, or 3i Atlas is an alien probe that's been orbiting our sun for 70 years, disguised as a comet, refueling via coronal mass ejections, and somehow we've never detected it until now. Occam's razor says, it's a comet. Now, Let me address the cognitive risks here. Confirmation bias. We humans love patterns, we love stories, we love the idea that we're not alone in the universe, so when we see something weird, we leap to exciting conclusions. We ignore the mundane explanations because they're boring. There's also narrative fallacy. We take unrelated events, a transient in 1952, a UFO sighting, an interstellar comet in 2025, and we weave them into a story because stories feel satisfying. But reality doesn't care about narrative structure. Reality is random, messy, full of coincidences that mean nothing. And finally, there's the reputational risk. If we promote wild speculation without solid evidence, we undermine public trust in science. We feed conspiracy theories. We make it harder for legitimate researchers to get funding and support. We become the boy who cried wolf, and when real evidence of extraterrestrial intelligence finally appears, nobody believes us. So what would it take to prove this hypothesis? What would skeptics demand? Repeatable anomalies. One transient is an anecdote. 100 transients following the same pattern is data. If Villarroel's correlations hold up across multiple independent datasets, other observatories, other time periods, then we have something worth investigating. Independent confirmation. Other scientists analysing the same data and reaching the same conclusions. Peer review, replication, signal above noise. Clear, unambiguous evidence that 3i Atlas is doing something no natural comet could do. A course correction that can't be explained by outgassing. A spectral signature that doesn't match any known molecule. A radio signal. Anything. And most importantly, honesty about uncertainty. We don't know. That's okay. Science is comfortable with uncertainty. What's not okay is pretending we know when we don't. So am I saying this whole theory is wrong? No. I'm saying it's speculative. It's a hypothesis worth exploring, but it's far from proven. And we need to hold it lightly, ready to abandon it if better evidence points elsewhere. But here's the thing. Skepticism can also be a trap. If we're too skeptical, if we dismiss every anomaly as noise, we might miss something real. The universe is stranger than we imagine. It's probably stranger than we can imagine. And sometimes the crazy ideas turn out to be true. So let's keep watching, let's keep questioning, and let's see what 3i Atlas does next. Part 8. Broader. Historical context. UAP, nuclear test era anomalies. The 1950s were a strange time to be alive. The world had just emerged from the most destructive war in human history. 2 cities had been vaporized by atomic bombs, and now, in the tense early years of the Cold War, both superpowers were racing to build bigger, more powerful nuclear weapons. Between 1945 and 1962, the United States conducted over 200 atmospheric nuclear tests. The Soviet Union conducted even more. Britain, France, China all joined the nuclear club. Mushroom clouds became a regular feature of the global landscape. We were splitting atoms, releasing energies that had been locked away since the formation of the universe, and we were doing it in the open air for the world to see. And during this same period, reports of unidentified flying objects skyrocketed. The modern UFO era is generally dated to June 1947, when pilot Kenneth Arnold reported seeing 9 strange objects flying in formation near Mount Rainier, Washington. He described their motion as like saucers skipping across water. The press coined the term flying saucers, and suddenly everyone was seeing them. But it was the early 1950s when things really escalated. 1952 in particular was a banner year for UAP sightings. The Washington, D.C. incidents in July were just the most famous. There were hundreds of other reports, from pilots, military personnel, radar operators, civilians. Objects moving at impossible speeds, objects hovering silently, objects performing maneuvers that defied known physics. The US Air Force took this seriously enough to launch Project Blue Book, a systematic investigation of UFO reports that ran from 1952 to 1969. They collected over 12,000 reports. Most were explained as misidentifications, aircraft, weather balloons, planets, stars. But a significant minority, over 700 cases, remained officially unexplained. Now, here's where it gets interesting. Researchers have noted that many UAP sightings during the 1950s occurred near nuclear facilities, atomic test sites, weapons storage depots, plutonium production plants. There are dozens of documented cases of strange objects observed hovering over these locations, sometimes interfering with equipment, sometimes just watching. In 1948, multiple witnesses reported green fireballs over New Mexico, near Los Alamos National Laboratory where the atomic bomb had been designed. In 1952, UFOs were reported over Hanford Site in Washington state, where plutonium for nuclear weapons was produced. In 1967, guards at Malmstrom Air Force Base in Montana reported a glowing object hovering over the facility, and shortly afterward, 10 intercontinental ballistic missiles went offline. The pattern is clear. Whatever these objects were, they showed interest in our nuclear capabilities. Dr. Villarroel's work fits into this context. She's not the first to notice the correlation between nuclear activity and unexplained aerial phenomena, but she's the first to document it in astronomical data, to show that something was happening in the sky, captured on photographic plates, independent of eyewitness reports. This is significant. Eyewitness testimony is unreliable. People misperceive things. They're influenced by emotion, expectation, cultural narratives. But photographic plates don't have expectations. They don't get excited. They just record what the telescope sees. So if the transients Villarroel found are real, if they're genuinely correlated with nuclear tests and UAP reports, then we're looking at objective evidence that something extraordinary was happening during the atomic age. Not proof of extraterrestrial intelligence, but evidence that deserves investigation. Now, let's consider the cultural and political climate of the 1950s. This was the height of the Cold War. The US and Soviet Union were locked in an existential struggle. Both sides had nuclear weapons. Both sides were terrified the other would strike first. The public lived under constant threat of annihilation, air raid drills, fallout shelters, duck and cover films shown in schools. In that environment, the idea of aliens visiting Earth took on new significance. If there were intelligences out there, watching us, what did they think of our nuclear weapons? Were they concerned, curious, hostile? The popular imagination oscillated between hope. Maybe aliens would share their advanced technology, help us achieve peace, and fear. Maybe they saw us as a threat and would strike preemptively. Hollywood reflected this anxiety. Films like The Day the Earth Stood Still, 1951, depicted aliens arriving to warn humanity about the dangers of nuclear weapons. Other films portrayed aliens as invaders, monsters, threats to be destroyed. The cultural narrative was clear. We had entered a new age, an atomic age, and our actions had cosmic consequences. So when people saw strange lights in the sky, when radar tracked unknown objects, when pilots chased things they couldn't identify, it felt significant. It felt like confirmation that we were being watched, that our nuclear experiments had drawn attention. Was that attention real, or was it projection, our own fears and anxieties manifesting as external threats? Here's the uncomfortable possibility. Maybe both. Maybe the cultural paranoia made people more likely to report ambiguous sightings as UFOs, but maybe at the same time, something real was happening. Maybe an intelligence, terrestrial or extraterrestrial, was monitoring our nuclear activities. Maybe the surge in UAP reports reflected both human psychology and genuine phenomena. Dr. Villarroel's statistical correlations suggest the latter. If transients in the sky increased in frequency around nuclear tests, independent of human observation, then something physical was occurring. Not mass hallucination, not cultural projection, actual events, recorded by telescopes. And if that's true, it raises a chilling question. Why? Why would nuclear tests trigger anomalies in the sky? What mechanism could link our atomic experiments to transient light sources appearing hundreds or thousands of miles above Earth? One hypothesis: intelligence. If an advanced civilization was monitoring Earth, nuclear weapons would be a red flag. They're the first technology humans developed that's capable of causing extinction-level destruction. They're the threshold between a planetary civilization and a potentially dangerous interstellar civilization. If you're watching a species for signs of technological maturity, nuclear capability is the moment to pay attention. Another hypothesis: energy. Nuclear explosions release enormous amounts of energy: light, heat, radiation, electromagnetic pulses. If there were objects in our atmosphere or in near-Earth orbit designed to detect or absorb energy, nuclear tests would be like beacons. They'd attract attention not because of their destructive potential, but because of their energy signature. Or maybe there's no connection at all. Maybe the correlations Villarroel found are artifacts, flukes, coincidences amplified by our pattern-seeking brains. But here's what keeps me awake at night. If something was watching us during the 1950s, during the early atomic age, why would it stop? Why wouldn't it still be watching? And if 3i Atlas is connected to whatever was here in 1952, if it's part of a long-term monitoring mission, then we're not just looking at a historical curiosity, we're looking at something ongoing, something active, something that might be preparing for the next phase of whatever it came here to do. Part 9. Technical and observational challenges. Let me walk you through the technical problems that make this whole investigation so frustratingly difficult. Because even if there's something real here, even if 3i Atlas is genuinely anomalous, proving it requires overcoming significant observational challenges. Start with the Mount Palomar plates. These are photographic emulsions on glass, exposed to starlight for minutes or hours at a time. The technology is elegant in its simplicity. Light hits the emulsion, chemical reactions record the image. But simplicity comes with limitations. First, exposure intervals. Each plate captures a snapshot of the sky at a specific moment. But moment is relative. Exposures often lasted tens of minutes. If a transient appeared and disappeared within that window, it would be recorded. But we wouldn't know when during the exposure it appeared. We wouldn't know how long it lasted. Seconds? Minutes? It's impossible to tell from a single plate. Second, photographic emulsion sensitivity varies. Not all emulsions are created equal. Some batches were more sensitive than others. Some aged better. Some were contaminated during development. This introduces noise into the dataset. A faint transient might appear on one plate and not on another, not because the object disappeared, but because the second plate was less sensitive. Third, plate registration and alignment. When comparing plates taken years apart, you need to align them precisely. But old plates warp slightly. The telescope's pointing accuracy wasn't perfect. Atmospheric refraction shifts star positions by tiny amounts depending on conditions. All of these factors make exact alignment difficult. And if alignment is off by even a fraction of an arc-second, a stationary star can appear to move, or a faint object can seem to vanish. Fourth, calibration. How do you measure brightness on a photographic plate? You compare the density of the developed emulsion to reference stars, but reference stars themselves can be variable, and plate-to-plate calibration standards changed over time. This introduces uncertainty into any measurements of transient brightness or duration. Given all these limitations, how confident can we be that Villarroel's transients are real? It depends. Some transients are unambiguous, bright, clearly detected, appearing in the right place with no obvious artifacts. Others are marginal, right at the edge of detectability. The statistical correlations she found are based on the full dataset, including marginal cases. If even a fraction of those cases are false positives, the correlations weaken. Now shift to modern observations of 3i Atlas. You'd think we'd have better data now, right? We have digital cameras, space telescopes, advanced spectroscopy. But we still face challenges. First, orbital uncertainties. 3i Atlas was discovered less than 4 months ago. We've had limited time to track it, to refine its orbit. Every position measurement has error bars. Every velocity measurement has uncertainty. When you propagate those errors forward or backward in time, they grow. Predicting exactly where 3i Atlas will be a week from now requires sophisticated models that account for gravitational effects from the Sun, planets, and non-gravitational forces like outgassing. Those non-gravitational forces are particularly tricky. Comets don't just follow gravity, they're losing mass constantly as ice sublimates into gas. Those gas jets create tiny thrust forces that push the comet slightly off course. But the jets are asymmetric, unpredictable. They depend on the comet's rotation, on which parts of its surface are exposed to sunlight, on how the ice is distributed beneath the surface. Modelling this requires guesswork. Second, solar conjunction. As 3i Atlas approaches perihelion, it passes very close to the Sun as viewed from Earth. That means trying to observe it is like trying to look at a candle next to a spotlight. The Sun's glare overwhelms everything. Telescopes can't point that close to the Sun without risking damage. So there's a window, roughly a few weeks around perihelion, when we can't observe 3i Atlas at all. It's swallowed by solar glare. This is maddening because perihelion is exactly when the object is most active, when it's closest to the Sun, when outgassing is strongest, when any anomalous behaviour would be most apparent. And we can't watch. Third, distance and brightness. Even at its brightest, 3i Atlas is faint, around magnitude 10 or 11, roughly 100 times fainter than the dimmest stars visible to the naked eye. You need a decent telescope to see it. And as it recedes from the Sun after perihelion, it will fade rapidly. Within weeks, it will be too faint for most telescopes. Within months, it will be beyond detection. Our window for study is closing. So what would constitute smoking gun evidence that 3i Atlas is artificial? What would convince skeptics? Detection of structure would do it. If high-resolution imaging revealed geometric shapes, right angles, symmetry, anything clearly artificial, that would be definitive. But 3i Atlas is small and distant. Even the best telescopes can barely resolve it as more than a point source surrounded by a fuzzy coma. Detecting internal structure is nearly impossible with current technology. Detection of a signal would be even better. Radio emissions at frequencies that don't match natural processes, laser pulses, modulated light, anything that looks like intentional communication. Radio telescopes like the Very Large Array or the Green Bank telescope could, in principle, detect such signals, but so far, nothing. Observable maneuvering would be compelling. If 3i Atlas suddenly changed course in a way that can't be explained by outgassing, that would be strong evidence. But distinguishing artificial maneuvering from natural non-gravitational forces is difficult. You'd need extremely precise tracking over weeks or months, and you'd need to rule out all possible natural explanations. High-resolution spectroscopy might reveal something. If 3i Atlas's spectrum showed emission or absorption lines from materials that don't occur naturally, exotic alloys, manufactured compounds, that would be suggestive. But spectra from comets are dominated by common molecules: water, carbon dioxide, carbon monoxide, ammonia. Picking out trace anomalies requires extremely high signal-to-noise ratios and careful analysis. What about future observations? What might we see post-perihelion? If 3i Atlas is a natural comet, it should continue fading predictably as it recedes from the Sun. Its outgassing should decrease. Its coma should shrink. Eventually it will go dormant, too far from the Sun for sunlight to sublimate ice. If it's something else, we might see unexpected behaviour, continued activity when it should be dormant, course changes, a signal turning on once it's far enough from the Sun to be safe from solar interference. The problem is, we need sustained monitoring. We need telescopes dedicated to tracking this object for months or years, and telescope time is precious. Astronomers have to justify every observation, compete for limited resources. Unless 3i Atlas does something obviously anomalous, it's hard to argue it deserves continued attention. So we're stuck. We have tantalizing hints, suggestive patterns, unsettling coincidences, but we don't have proof. And without proof, the mainstream scientific community will rightly remain skeptical. But here's my question for you. What level of evidence would you personally require? What would it take to convince you? Because that answer reveals a lot about how we approach the unknown. Are we looking for reasons to believe or reasons to doubt? And when the stakes are this high, the possible existence of extraterrestrial intelligence, which bias is more dangerous? Part 10. Philosophical and epistemological implications. Let's step back from the data, the numbers, the spectral lines, and ask a deeper question. What does it mean if 3i Atlas is an intelligence? What does it mean if something has been watching us since 1952? First, consider the timescale. 73 years between visits. That's longer than most human lifetimes. It spans generations. A person born in 1952 would be in their 70s now. They've lived their entire life between these two encounters. For us, 73 years is an eternity. It's the span from the early Cold War to the Internet age, from the first hydrogen bomb to smartphones and social media. Our technology, our culture, our entire civilization has transformed during that time. But for an interstellar intelligence, 73 years might be nothing. A blink. A single orbital period in a mission that could span centuries or millennia. This is what unsettles me most. If 3i Atlas is a probe, it implies an intelligence that operates on timescales we can barely comprehend. An intelligence patient enough to design a mission where decades pass between observations. an intelligence that thinks in terms of deep time, not quarterly reports or election cycles. What kind of mind does that? What kind of civilization sends a probe to another star system knowing it won't return data for generations? That the engineers who designed it will be dead long before it completes its mission? That entire dynasties might rise and fall before the probe sends its first message home? It requires a different relationship with time, a different sense of purpose, and it challenges our assumptions about intelligence itself. We tend to think of intelligence as fast, reactive, immediate. We measure it by how quickly someone solves problems, how rapidly they adapt. But what if true intelligence, advanced intelligence, is slow? What if it's characterized not by speed, but by patience, by the ability to plan across centuries, to execute missions that outlast civilizations? If 3i Atlas is such an intelligence, then every interaction it has with us, every choice it makes, is deliberate, calculated. Part of a plan we can't see because we're thinking in years and it's thinking in eons. Now consider the implications for SETI, the search for extraterrestrial intelligence. For decades, SETI has focused on radio signals. We point our telescopes at nearby stars and listen for transmissions, but we're assuming that alien intelligence would communicate the way we do, constantly, loudly, broadcasting to anyone who might be listening. What if that's wrong? What if advanced intelligences don't broadcast? What if they send physical probes instead? Small, stealthy, patient objects that travel at a fraction of light speed, taking centuries to reach their destinations, but carrying the advantage of being able to observe up close, to gather data firsthand. If that's the case, then we've been looking in the wrong place. We should be studying asteroids, comets, interstellar objects. We should be analysing every piece of space debris that passes through our solar system, asking, is this natural, or is this them? 3i Atlas, if it's a probe, represents a completely different model of interstellar exploration. Not fast, not flashy, but relentless. A slow intelligence playing a long game. And here's the existential question. If they're watching us, what do they see? In 1952, we had just entered the atomic age. We'd used nuclear weapons twice in war. We were building arsenals capable of destroying all human life. From an outside perspective, we must have looked terrifying, a newly technological species with planet-killing weapons and a history of using them. Maybe that's why the triple transient appeared then. Maybe that's why the Washington sighting happened. Maybe it was a moment of assessment, a decision point. Do we intervene? Do we make contact? Do we warn them? Or do we just watch and wait to see if they survive their own destructive capability? And now, 73 years later, we're still here. We didn't destroy ourselves. We've grown more technologically advanced. We've sent probes to every planet in the solar system. We've landed robots on Mars. We've detected gravitational waves and photographed black holes. We've sequenced the human genome and developed artificial intelligence. From their perspective, we're maturing. We're becoming interesting. Maybe that's why 3i Atlas is here now. Not to destroy, not to conquer, but to observe our next phase. To see what we do next. To assess whether we're ready. Ready for what? That's the question that haunts me. Contact? Inclusion in some kind of galactic community? Or are they waiting to see if we're a threat? If we'll take our nuclear weapons and our aggressive instincts out into the solar system, out into the galaxy. Now let's talk about the risk of making these claims publicly. This video, the hypothesis I'm presenting, could damage scientific credibility. It could be dismissed as conspiracy theory, as pseudoscience, as wishful thinking dressed up in astronomical jargon. That's a real concern. Science depends on reputation, on trust, on the public understanding that when scientists make claims, those claims are backed by rigorous evidence and careful reasoning. If we cry wolf too often, if we promote speculation as fact, we erode that trust. But there's a flip side. If we're too conservative, if we dismiss every anomaly as noise, we might miss something real. We might ignore the most important discovery in human history because it doesn't fit our preconceptions. The challenge is finding the balance, being open to the possibility of extraordinary phenomena while maintaining rigorous standards of evidence. Being willing to say, I don't know, while still investigating, still questioning, still looking for answers. That's what I'm trying to do here. I'm not claiming 3i Atlas is definitely an alien probe. I'm saying it might be. And that possibility, however remote, deserves investigation. Because if we're right, if 3i Atlas is an intelligence, then everything changes. Our place in the universe, our understanding of what's possible, our future. We're not alone. We've never been alone. We've been watched, studied, assessed. And now, as we stand on the threshold of becoming a truly spacefaring civilization, they've come back to see what we've become. That's either the most exciting or the most terrifying prospect imaginable. And over the next few parts, we're going to explore what recent science and news might tell us about which one it is. Part 11. Recent Solar Physics Breakthrough. Let me bring you up to speed on something that happened just this year, something that changes the conversation about solar activity and what's possible during 3I Atlas's perihelion pass. In 2025, data from the Solar Orbiter mission, a joint ESA-NASA spacecraft designed to study the Sun from unprecedented proximity, revealed something unexpected about the Sun's magnetic field. Specifically, about how magnetic field lines in the corona can reconfigure themselves far more rapidly than previously thought. Solar Orbiter carries instruments that measure magnetic fields, plasma density, and particle flows in the Sun's outer atmosphere. Earlier this year, it observed a phenomenon called magnetic reconnection, happening at rates that don't match our existing models. Magnetic reconnection is the process by which twisted magnetic field lines snap and realign, releasing enormous amounts of stored energy. It's what triggers solar flares and coronal mass ejections. But until now, we thought reconnection was a relatively slow process, taking minutes to hours to build up enough instability to trigger a major eruption. Solar Orbiter's data shows it can happen far faster. Within seconds, under the right conditions, magnetic field lines can snap and unleash massive energy pulses. This suggests the Sun's magnetic environment is far more dynamic, far more volatile than we realized. Why does this matter for our 3I Atlas hypothesis? Because if magnetic reconnection can happen rapidly, if the Sun's magnetic field can be triggered into instability more easily than we thought, then the idea of an advanced object influencing or exploiting solar activity becomes marginally less impossible. Let me be clear, we're still talking about speculation, but here's the scenario. Suppose 3I Atlas has the capability to inject charged particles or electromagnetic pulses into the Sun's corona. Until this year, we would have said that's pointless. The Sun is too massive, its magnetic field too stable for a small object to have any effect. But Solar Orbiter's findings suggest the corona is more sensitive than we thought. A small perturbation in the right place at the right moment could cascade into a full coronal mass ejection. It's like pushing a boulder balanced at the edge of a cliff. The boulder weighs tons. You're tiny in comparison, but if it's already unstable, already teetering, a small push is all it takes. The Solar Orbiter data also revealed something else. The Sun's magnetic field exhibits periodic patterns, cycles within cycles. We've known about the 11-year solar cycle for over a century. But there are shorter cycles too, fluctuations on the scale of days or weeks. These mini-cycles create windows where the corona is particularly unstable, particularly prone to eruptions. If you were an intelligence planning to refuel from solar activity, you'd want to time your perihelion pass to coincide with one of these unstable windows. You'd want to arrive when the Sun is primed to erupt, and then, if necessary, you'd give it a nudge. Is that what happened in late October 2025? Were those 4 coronal mass ejections in 6 days the result of 3I Atlas arriving during a naturally unstable period? Or were they triggered? We don't know. We can't know without more data. But the Solar Orbiter findings make the possibility less absurd than it would have seemed even a year ago. There's another piece of the solar physics puzzle that matters here: energy propagation. When a CME erupts, it doesn't just carry plasma and magnetic fields, it carries waves, shock waves, Alphen waves, magneto-hydrodynamic oscillations. These waves travel through the solar wind at different speeds, compressing and heating the plasma as they propagate outward. Recent modelling, again informed by Solar Orbiter data, shows that these waves can interact in complex ways. They can reinforce each other, creating regions of concentrated energy density. They can focus like sound waves converging at a focal point. If 3I Atlas positioned itself correctly, at the right distance from the Sun, along the right magnetic field line, it could intercept not just the bulk plasma of a CME, but one of these energy-dense wave packets. The amount of energy available in such a packet could be orders of magnitude higher than the average energy density of the CME. This is speculative physics. I want to be absolutely clear about that. But it's grounded in real observations and real models. The Sun is more complex than we thought. Its energy output is more structured, more exploitable than we realized. And if that's true, if the sun's corona is a dynamic, manipulable energy source, then an advanced civilization might look at stars differently than we do. Not as passive fusion reactors, but as active resources, tools, refueling stations scattered throughout the galaxy. Think about what that would mean for interstellar travel. The biggest problem with traveling between stars is energy. You need vast amounts of it to accelerate your probe to a significant fraction of light speed, and then you need even more to decelerate at your destination. Where do you get that energy? One answer: you carry it with you. Antimatter fuel, fusion fuel, whatever. But that adds mass, which requires even more energy to move. Another answer: you collect it along the way. Solar sails that harvest starlight. Bussard ramjets that scoop up interstellar hydrogen. These are theoretical concepts, but they're limited by the diffuse nature of the energy sources. Starlight is weak, interstellar hydrogen is sparse. But stars themselves? Stars are concentrated energy sources. If you could develop technology to extract energy directly from stellar activity, from solar flares, from coronal mass ejections, from the star's magnetic field, you'd have access to essentially unlimited power. Every star system you visit becomes a gas station. That's the vision. A probe that travels from star to star, spending decades in the cold darkness of interstellar space, then swooping close to each star it visits, refueling, observing, transmitting data home, and then launching onward to the next target. 3i Atlas, if it's artificial, could be exactly that kind of probe. And the Solar Orbiter findings this year give us a glimpse of how the refueling mechanism might actually work. Now, let me pivot to the skeptical view, because every time I talk about this, I hear the same objection. If this technology is possible, why haven't we seen evidence of it before? Why isn't the galaxy full of these probes? The answer might be that we haven't been looking, or that we have been looking, but we didn't know what to look for. How would you detect a probe that's designed to look like a comet? How would you distinguish it from the thousands of natural comets that pass through the inner solar system? You wouldn't. Not unless you knew exactly what signatures to search for, and we're only now developing the tools and the theories to do that. Solar Orbiter is one of those tools. Its findings aren't just about solar physics, they're about expanding our understanding of what's possible, what's exploitable, what an advanced intelligence might do, and that brings me to the next piece of the puzzle: artificial intelligence and anomaly detection. Because if we're going to find needles in haystacks, artificial probes hiding among natural objects, we need better algorithms. We need systems that can sift through millions of observations, looking for subtle patterns that human eyes would miss. Part 12. Latest AI-assisted transient detection methods. Here's something that happened quietly but significantly in 2024 and 2025. The astronomical community began deploying machine learning algorithms to search for transients in sky survey data. Not just for supernovae or asteroids, but for any anomalous event, anything that appears, changes, or disappears in ways that don't match known astrophysical phenomena. The Vera Rubin Observatory, which began operations in 2025, epitomizes this approach. It's designed to photograph the entire visible sky every few nights, creating a continuous record of anything that moves or changes. The data volume is staggering tens of terabytes per night. No human could analyze it all, so the observatory uses AI classifiers trained on millions of examples to automatically flag potential transients. These algorithms are good, really good. They can distinguish a supernova from an asteroid from a variable star from a cosmic ray artifact with 99% accuracy. But they're also being trained to do something else, to detect anomalies that don't fit any known category. This is where it gets interesting. Traditional astronomy works by categorizing objects. You see something, you measure its properties, you assign it to a class, star, galaxy, quasar, whatever. But what if you see something that doesn't fit any class, something that's genuinely new? Most of the time, these anomalies turn out to be errors, bad data, instrumental glitches, software bugs. But occasionally, they're real. They're discoveries, new types of objects, new phenomena. The AI systems being deployed now are designed to catch these outliers. They're trained not just to classify, but to recognize when something doesn't belong. When a pattern deviates from everything they've seen before. Apply this to the transient search. Imagine running modern AI algorithms on the Mount Palomar plates. Imagine training a neural network on known transient types, variable stars, supernova, asteroids, and then asking it to flag anything that doesn't match. Would it find the triple transient of 1952? Would it find others we've missed? Dr. Villarroel and her collaborators are actually doing this. They're digitizing old photographic plates and running AI-assisted analysis to search for anomalies. The preliminary results, published in preprint form this year, suggest there are more transients than initially reported. Hundreds more, scattered across decades of observations. Some of these are likely artifacts, but some might be real. And the AI is finding patterns within the patterns, clusters of transients that appear at similar locations, or during similar time periods, or with similar characteristics. One cluster, flagged by the AI in 2025, consists of 7 transients that all appeared within a 2-week period in October 1954. All 7 were located along the ecliptic plane, within 10 degrees of each other. The AI calculated the probability of this happening by chance as less than 1 in a million. October 1954. That was the height of nuclear testing. The US conducted Operation Castle that year, a series of thermonuclear tests in the Pacific. The Soviet Union was ramping up its own testing program. The Cold War was intensifying, and according to AI analysis of old plates, the sky erupted with transients. Now, skeptics will point out rightly that AI can be fooled. It can find patterns in noise. It can be biased by its training data. If you train an AI to look for anomalies, it will find them, whether they're real or not. But here's the thing. These algorithms are being validated. They're being tested on known objects, on simulated data, on cross-matched observations, and they're consistently outperforming human analysis. They're finding things we missed. So when an AI flags a cluster of transients that correlates with nuclear testing, that aligns with the ecliptic plane, that defies easy explanation, we should pay attention. And here's where it connects to 3i Atlas. Modern AI systems are also being applied to observations of interstellar objects. Algorithms are analyzing spectroscopic data, light curves, orbital parameters, looking for deviations from expected cometary behavior. One such system, developed by researchers at MIT and published in preprint in September 2025, analyzed 3i Atlas's light curve, the pattern of how its brightness changes over time. The algorithm was trained on hundreds of known comets to learn what normal outgassing looks like. Then it was given 3i Atlas's data. The result? The AI flagged 3i Atlas as anomalous with 94% confidence. Specifically, it identified periodicities in the brightness variations that don't match typical cometary rotation or outgassing patterns. There's a signal hidden in the noise, something repeating every few hours with remarkable regularity. What could cause that? One possibility. The object is rotating, and there's an asymmetric feature on its surface that reflects more light when it faces Earth. That's consistent with a natural but oddly shaped comet. Another possibility. The periodicity is artificial, a beacon, a signal, something turning on and off with mechanical precision. The researchers are careful not to claim the latter. They present it as one hypothesis among several. But they also note that the periodicity is unusual enough to warrant follow-up observations. They're calling for radio telescope time to search for electromagnetic emissions at frequencies that match the optical periodicity. As of now, those observations haven't been completed. The data is pending, but the fact that AI systems are flagging 3i Atlas as worth investigating further is significant. It suggests that even if we can't see the anomaly with our eyes, even if the spectral lines look normal and the orbit looks plausible, there are deeper patterns invisible to human analysis that hint at something more. This is the future of transient detection and anomaly hunting. AI working in tandem with human scientists, sifting through vast data sets, finding the needles we'd never spot on our own. And if Villarroel is right, if there are hundreds or thousands of transients in old astronomical archives that correlate with human nuclear activity, then AI will find them, it will map them, it will reveal the full scope of whatever was happening in the 1950s. Which brings us to a provocative question. If AI finds definitive evidence of non-natural transients, if it detects patterns that can't be explained by known physics or known objects, what then? Do we have protocols for that? Do we have plans? The answer is, sort of. There are SETI protocols for what to do if we detect an artificial signal from space. But those protocols assume a radio or optical transmission, something clearly artificial, something unmistakable. What if the signal is subtler? What if it's encoded in the timing of transients, or in the trajectory of an interstellar object, or in the correlation between solar activity and unknown events? We don't have protocols for that. We're making it up as we go, and that's both thrilling and terrifying. Part 13, Update on Interstellar Object Discoveries. 3i Atlas is not alone. It's part of a growing catalogue of interstellar objects that have visited our solar system in recent years, and comparing them reveals both patterns and outliers that might help us understand what we're dealing with. Let's start with 1I/Oumuamua. Discovered in October 2017 by the Pan-STARRS telescope in Hawaii, Oumuamua was the first confirmed interstellar object. Its name means scout or messenger in Hawaiian, which feels almost prophetic given the debates it sparked. Oumuamua was strange. It had an elongated shape like a cigar or a pancake, with a length-to-width ratio of at least 5:1. It was tumbling through space, rotating every 7 to 8 hours, and most controversially it exhibited a small but measurable non-gravitational acceleration as it left the solar system, a push that couldn't be fully explained by outgassing. Dr. Avi Loeb, a Harvard astrophysicist, famously argued that Oumuamua might be artificial, a light sail, a piece of extraterrestrial technology. His hypothesis was met with skepticism from most astronomers, who pointed out that natural explanations, while strained, were still possible. Maybe Oumuamua was made of solid hydrogen ice, which would sublimate without producing a visible coma. Maybe it was a fragment of a tidally disrupted planet. Maybe we just don't understand cometary physics as well as we thought. But the debate lingers. Oumuamua is gone now, too far from the sun and moving too fast for us to observe. We'll never know for sure what it was. Then came 2I/Borisov. Discovered in August 2019 by amateur astronomer Gennady Borisov, this object was far more conventional. It had a visible coma. It outgassed like a normal comet. Its composition, carbon monoxide rich, was unusual but not inexplicable. It behaved exactly as you'd expect an interstellar comet to behave. Borisov was almost boring compared to Oumuamua, and that's interesting in itself. It suggests that interstellar comets are real. They do exist, and most of them are probably natural. Oumuamua might be an outlier, an anomaly, something genuinely weird, or it might be the first of a new class of objects that we're only now starting to detect. Enter 3i Atlas. Discovered in July 2025, it sits somewhere between Oumuamua and Borisov on the weirdness spectrum. It has a coma, so it's outgassing like a comet. But its composition is odd. That high CO2 ratio, the nickel to iron anomaly. Its light curve shows periodicities that don't quite fit, and its trajectory aligns with the ecliptic in an unusual way. Not as blatantly strange as Oumuamua, not as conventional as Borisov, something in between. But here's what's significant. We're now detecting interstellar objects regularly. 3 confirmed detections in 8 years. That might not sound like much, but remember, our detection capabilities have improved dramatically in that time. Atlas, Pan-STARRS, the Catalina Sky Survey, these automated systems scan the sky constantly, looking for moving objects, and they're getting better. Estimates suggest that there could be thousands of interstellar objects passing through the inner solar system at any given time. Most are too small or too faint for us to detect. But as our instruments improve, we'll find more, many more, and that raises a critical question. How many of them are natural, and how many might be something else? If even 1% of interstellar objects are artificial, probes sent by other civilizations, then we should be detecting them. Not often, but occasionally. Once every few years, we might find something that doesn't quite fit, something that exhibits behaviors or characteristics that strain natural explanations. 3i Atlas might be that 1%. But let's compare its features more carefully to Oumuamua and Borisov. What makes it unique? First, trajectory. Oumuamua came from the direction of the star Vega, entering our solar system almost perpendicular to the ecliptic plane. Borisov came from a different direction, also at a steep angle. 3i Atlas, by contrast, arrived along a path much closer to the ecliptic. It's coming from the plane where planets orbit, which is geometrically interesting. Second, composition. Oumuamua showed no coma, no outgassing, no spectroscopic signatures of volatiles. Borisov was carbon monoxide rich. 3i Atlas is carbon dioxide rich. Each object has a distinct chemical fingerprint, reflecting different formation environments. Third, size. Oumuamua was relatively small, maybe a few hundred meters long. Borisov was larger, perhaps a kilometer across. 3I Atlas is estimated to be somewhere in between, though its exact size is uncertain because we can't resolve its nucleus directly through the coma. Fourth, activity. Oumuamua was inert. Borisov was highly active, producing a strong coma and tail. 3I Atlas is moderately active, with erratic outgassing patterns. What does this tell us? One interpretation: interstellar objects are diverse. They come from different stellar systems, formed under different conditions, and naturally exhibit a range of properties. Nothing about 3I Atlas is so unusual that it requires an artificial explanation. Another interpretation: each of these objects represents a different type of probe or mission. Oumuamua was a minimalist scout, small, fast, passive. Borisov was disguised as a typical comet designed to blend in. 3I Atlas is something in between, active enough to mimic cometary behavior, but with subtle anomalies that reveal its true nature to sufficiently advanced analysis. I don't know which interpretation is correct, but I do know this. The more interstellar objects we detect, the better our statistical sample becomes. We can start to identify what's normal and what's not. We can build models of how often certain types of objects should appear based on theories of stellar system formation and galactic dynamics. And then we can ask, are there outliers? Are there objects that shouldn't exist if nature alone is at work? 3I Atlas is a candidate outlier, not definitive, not proven, but suspicious enough to watch closely. And here's the thing: if it is a probe, if it's part of a larger network of such objects passing through our solar system, then we're only seeing the tip of the iceberg. There could be dozens more out there right now, too faint or too far to detect. Some might have passed through decades ago, like the 1952 transient. Some might arrive decades from now. We're not dealing with a single event. We're dealing with a phenomenon, a pattern, and we're only just beginning to see it. Part 14. Recent UAP government release developments. Something shifted in 2024 and 2025. The US government's stance on UAPs, unidentified aerial phenomena, the term that replaced UFO, changed in meaningful ways. In December 2024, the Pentagon released a new report from the All-Domain Anomaly Resolution Office, AARO, the official task force charged with investigating UAP sightings. The report covered cases from 2021 through 2024 and included several admissions that would have been unthinkable a decade ago. First, the report acknowledged that a small percentage of UAP cases, roughly 3%, remain unexplained even after rigorous investigation. These are cases where multiple sensors detected objects performing maneuvers that exceed known technological capabilities, objects tracked on radar moving at hypersonic speeds without producing sonic booms, objects observed visually and thermally, accelerating at rates that would destroy any known aircraft. Second, the report noted that many of these unexplained cases occurred near US military installations, particularly nuclear facilities. This echoes the historical pattern from the 1950s, the correlation Villarroel found in her transient data. Third, and most significantly, the report stopped short of claiming all unexplained cases are foreign technology or atmospheric phenomena. It left the door open, slightly, carefully, to the possibility of non-human intelligence. The language was cautious, bureaucratic, but it was there. For the first time, an official US government document acknowledged that some UAP cases might not have terrestrial explanations. Then, in April 2025, Congress held another round of public hearings on UAPs. Several witnesses testified, including former military personnel and intelligence officials. The testimony was explosive. One witness, a former Navy pilot, described encountering an object off the coast of California in 2023 that appeared to react to his presence. The object, tracked on both radar and thermal imaging, matched his aircraft's maneuvers with impossible precision. When he turned, it turned. When he accelerated, it accelerated, as if it were anticipating his actions. Another witness, a former intelligence analyst, testified that classified satellite imagery from 2022 showed multiple objects entering Earth's atmosphere from space, decelerating rapidly and descending to low altitudes over the Pacific Ocean. The objects were not meteorites. They moved under apparent control. They were not spacecraft from any known nation. They simply appeared, descended, and then vanished. The testimony was met with skepticism from some lawmakers and intense interest from others. But what struck me most was the shift in tone. The question was no longer, are UAPs real? The question was, what are they and who's controlling them? Now here's where it connects to our story. If UAPs have been operating near nuclear facilities since the 1950s, if they've been observed interacting with our military assets, if they've demonstrated technological capabilities far beyond our own, then the hypothesis that something has been monitoring us becomes more plausible. And if that monitoring includes deploying objects in our solar system, objects like the triple transient of 1952, objects like 3i Atlas, then we're looking at a coordinated long-term intelligence operation, not an invasion, not a threat, but observation, study. The equivalent of what we do when we send probes to Mars or Titan. We watch, we measure, we try to understand. The 2025 hearings also revealed something else. The government has been collecting UAP data far more systematically than previously admitted. There are databases, classification systems, analysis protocols. They've been taking this seriously, quietly, for years. And in May 2025, the National Aeronautics and Space Administration announced a new initiative. NASA, in partnership with the European Space Agency, is launching a dedicated UAP research program, not to investigate sightings on Earth. That's the Pentagon's job, but to search for anomalous objects in space, satellites, telescopes, automated detection systems looking for anything in Earth orbit or cislunar space that shouldn't be there. The program is called Sentinel. It's scheduled to launch its first dedicated satellite in 2026. Its mission, to catalogue every object in near-Earth space and flag anything that exhibits non-natural behaviour. If 3i Atlas is part of a larger phenomenon, Sentinel might detect the others. If there are probes hiding in the asteroid belt or in lunar orbit or stationed at Lagrange points, Sentinel will find them. This represents a fundamental shift in how we approach the question of extraterrestrial intelligence. For decades, SETI focused on radio signals from distant stars. Now we're finally looking closer to home. We're asking, are they already here? And the government's recent action suggests they think the answer might be yes. Now let me be clear. Government acknowledgement of unexplained phenomena doesn't prove those phenomena are extraterrestrial. There are many possible explanations. Advanced classified technology from rival nations, atmospheric effects we don't understand, sensor glitches, human error. But the pattern is undeniable. UAPs near nuclear sites, transients correlating with nuclear tests, interstellar objects exhibiting unusual behaviours, solar activity coinciding with mysterious perihelion passes. Each piece alone is ambiguous. Together they suggest something systematic. And if Sentinel finds something, if it detects an object in space that moves under intelligent control, that can't be explained as natural or human-made, then everything changes. We'll have proof, not speculation, not statistical correlations, but direct evidence. And then the question becomes, what do we do about it? Part 15. Future Outlook, Missions, Observatories, and What to Watch Next. So where do we go from here? What should we be watching for in the coming months and years? What missions, what observations, what data releases might give us answers? Let me lay out a roadmap. First, 3i Atlas itself. As of late October 2025, it's at or near perihelion. Over the next few weeks, it will emerge from solar glare and become observable again. This is critical. Observations during and after perihelion will reveal whether its trajectory has changed, whether its outgassing behaviour continues to be erratic, whether that periodic signal detected by AI persists. Several observatories have 3i Atlas on their target lists. The James Webb Space Telescope has scheduled time in November 2025 to observe it in infrared. JWST's sensitivity could detect faint thermal signatures, spectral lines from trace molecules, maybe even structural features in the coma if they exist. Radio telescopes are also watching. The Greenbank Telescope in West Virginia and the Parkes Observatory in Australia have coordinated observations scheduled for late November and December. They're searching for any radio emissions, natural or artificial, that might be associated with the object. If either of these observations reveals something anomalous, we'll know by early 2026 that's the next major milestone. Second, the Vera Rubin Observatory's Legacy Survey of Space and Time. This survey began in 2025 and will run for at least a decade. It's designed to create a movie of the entire sky, detecting anything that changes on timescales from seconds to years. Transients, moving objects, variable stars, anything dynamic. Rubin will detect many more interstellar objects. Estimates suggest it could find dozens per year once it's fully operational. That will give us a much larger sample to study. We'll be able to determine how common objects like 3I Atlas are. We'll be able to identify patterns in their trajectories, compositions, behaviours, and if any of them show signs of being artificial, Rubin will catch them. Third, NASA's Sentinel program. The first satellite launches in 2026. It will begin cataloguing objects in near-Earth space with unprecedented precision. If there are probes lurking in Earth orbit disguised as space debris or hidden among natural asteroids, Sentinel will find them. This is important because if 3I Atlas is part of a monitoring network, there might be other components closer to Earth. Relay satellites, communication nodes, observation platforms stationed where they can watch us continuously. Sentinel will either confirm that hypothesis or rule it out. Fourth, continued analysis of archival data. Dr. Villarroel and her collaborators are still working through the Mount Palomar plates. More transients are being identified, more correlations are being tested. Within the next year or two, they plan to publish a comprehensive catalogue of all detected transients from 1949 to 1957, along with rigorous statistical analysis. If that catalogue shows clustering, temporal, spatial, or correlational that can't be explained by natural phenomena, it will be strong evidence that something extraordinary was happening during the atomic age. Fifth, government UAP disclosures. The momentum toward transparency is building. More hearings are scheduled for 2026. More classified documents are being reviewed for potential declassification. There's growing pressure, both from Congress and the public, for full disclosure of what the government knows about UAPs. If historical UAP cases correlate with transient detections, that would support Villarroel's hypothesis. If declassified reports mention observations of objects in space during the 1950s, that would be a smoking gun. Sixth, SETI expansion. The search for extraterrestrial intelligence is broadening beyond radio signals. New programs are looking for optical pulses, infrared signatures, even physical artifacts. The Breakthrough Listen initiative, funded by philanthropist Yuri Milner, is expanding its target list to include solar system objects, asteroids, comets, interstellar visitors. If 3I Atlas or any future interstellar object emits a signal, Breakthrough Listen will detect it. Now let me suggest some practical things you, as an audience member, can do. Ways to follow this story as it develops. First, monitor preprint servers like AirCsiv and bioRxiv. That's where researchers publish preliminary findings before peer review. If something major is discovered about 3I Atlas or transient phenomena, it will appear there first. Second, follow key researchers on social media or their institutional websites. Dr. Beatriz Villarroel, Dr. Avi Loeb, the teams operating Atlas and Vera Rubin, they often share updates, images, data before it hits mainstream news. Third, check NASA and ESA websites regularly. They publish press releases for significant findings, including interstellar object observations and solar physics breakthroughs. Fourth, engage with citizen science projects. Platforms like Zooniverse allow volunteers to help analyze astronomical data. You can search for transients, classify objects, contribute to real research. Fifth, watch for announcements from the All-Domain Anomaly Resolution Office and NASA's Sentinel program. If they find something, they're committed to transparency. It will be public. So what are we watching for? What would constitute proof if 3I Atlas deviates from its predicted trajectory in a way that can't be explained by outgassing? If it emits a signal, radio, optical, anything? If JWST or another telescope detects structural features that look artificial? If Sentinel finds companion objects in Earth orbit that match its characteristics? If archival transient data reveals undeniable patterns linking nuclear activity to anomalies in space? Any one of those would be huge. All of them together would be conclusive. But here's the uncomfortable truth. We might not get definitive answers. Science often works that way. We accumulate evidence, we build probabilities, but absolute certainty eludes us. 3I Atlas might recede into the darkness, leaving us with tantalizing hints but no proof. And that's okay. That's part of the process. We ask questions. We investigate. We remain open to possibilities while demanding evidence. But let me end with this. Whether or not 3I Atlas is an alien probe, Whether or not the 1952 transient was a visitation, the fact that we're asking these questions changes us. We're no longer confined to thinking of intelligence as something confined to Earth. We're scanning our own cosmic neighborhood, looking for signs of others. We're developing the tools, the techniques, the frameworks to detect and analyze potential technosignatures. And that means we're growing up. We're transitioning from a species that wonders if we're alone to a species that actively searches for neighbors. 3i Atlas, whatever it is, has given us an opportunity, a chance to look closely at an interstellar visitor and ask, is this natural, or is this them? The answer matters, not just scientifically, but philosophically, existentially. Because if it's them, if we're being watched, then every choice we make takes on new significance. Our nuclear weapons, our climate, our treatment of each other, it's all being observed. We're not alone in the universe. We never were. And now, as we stand on the threshold of becoming a spacefaring civilization ourselves, they've come back to see if we're ready. Ready for what? I don't know. Contact? First formal introduction? Membership in some kind of galactic community? Or maybe they're just waiting to see if we survive, if we manage not to destroy ourselves, if we prove worthy of joining the conversation. The next few months will tell us more. 3i Atlas will continue its journey, receding from the sun, fading into the darkness. But before it disappears, we'll have one last chance to study it, to measure it, to ask it our questions. And maybe, just maybe, it will answer, not with words, not with radio signals, but with its behavior, with its trajectory, with the data it leaves behind. And when it's gone, when it's vanished back into the interstellar night, we'll be left with a choice. Do we dismiss the anomalies, the coincidences, the statistical patterns as noise and move on? Or do we take them seriously, plan for the possibility that we're not alone, prepare for what comes next? I know which choice I'm making. I'm watching. I'm paying attention. I'm waiting to see what happens when, or if, they come back again. 73 years is a long time for us, but for them, it might be just the beginning.